Good morning, students. Today our topic is AC circuit containing only in a inductor. Just consider one inductor. The self-induction of inductor is L, you know well, which is connected with the AC circuit. Ending AC circuit containing only in inductor. Before topic, you see AC circuit containing only in resistor. This is inductor. Next is capacitor. First one, I want to connect this alternating current. Alternating source connected with an inductor. This inductor. Self-induction of inductor is L. The alternating source V is equal to Vm sin omega t. The applied source voltage V is equal to Vm sin omega t. You know well the equations of induced EMF E is equal to E naught sin omega t. E naught is the maximum EMF, same phenomena. V is equal to Vm sin omega t. V is a voltage, applied voltage. This is a maximum voltage sin omega t. Sin omega, you know well, frequency and time. You know well. This alternative source. The flow of current is I. Flow of current is I. The self-induction of coil is L. You know well, according to Lenz's law, if the variable current flows through the coil, the magnetic flux is also changed. If the magnetic flux to produce a magnetic field around the coil. So, according to Lenz's law, the induced EMF, back EMF is also called as back EMF. The induced EMF produced against the applied voltage. You know well. So the induced EMF, E is equal to minus L into di divided by dt. This is equation number 1. This is equation number 2. You know well, E is equal to minus L into di by dt. E is directly proportional to di by dt. The induced EMF is directly proportional to rate of change of current. This is constant self-induction of the coil. So V is equal to Em sin omega t is applied source. In a pure inductor, V is equal to E. The applied voltage is equal to induced EMF V is equal to minus E because of the induced EMF against the applied voltage. If applying V is equal to minus E value, so V plus E is equal to 0. So V is equal to minus E. This is applied voltage. This is induced EMF in a ideal inductor. V is equal to minus E. So V is equal to minus E. What is the V value? Vm sin omega t is equal to E value. This is minus E. Minus of E value is equal to minus L into di divided by dt. This is the equation. I want to the applied equation. Applied voltage is equal to induced EMF. This is a main concept. So Vm is equal to Vm sin omega t is equal to minus into minus plus. So L di divided by dt. I want to calculate the applied AC current value. So AC current equation. Because of compare voltage, applied source voltage equation and current equations. That's why I want to calculate this. Di is equal to. So di divided by dt is equal to Vm divided by L. Vm divided by L sin omega t. Sin omega t. So di is equal to Vm divided by L. Vm is the maximum voltage in alternating current is a constant. L is the self-induction of coil. This is also constant. So di is equal to Vm divided by L into sin omega t into dt. This is the equation. So di is equal to. I want to calculate this I values, just I want to take in the integral, you know well. That's why I directly take this integral of di. I want to calculate overall current applied over AC current is equal to integral of Vm divided by L sin omega t into dt. Sin omega t into dt. So di is equal to I is equal to Vm divided by L is a constant. Vm divided by L is a constant. That's why I want to take this in a common factor. So constant I is equal to Vm divided by L integral of sin omega t into dt. Sin omega t into dt. So I is equal to Vm divided by L sin integral of sin omega t dt. You know well sin omega t is equal to minus cos omega t into omega t into dt is divided by omega. So I is equal to Vm divided by L into omega. So L omega minus cos omega t. So I want this is I is equal to Vm divided by L omega minus cos omega t. This is equations of alternating current equation. But the voltage is V is equal to Vm sin omega t. This is sine form, this is cos form. Just I want to take this cos form is convert to sine form. So I is equal to Vm divided by L omega minus of cos omega t, cos theta is equal to sin 90 minus theta. So sin 90 pi by 2 minus omega t. You know well. So I is equal to Vm divided by L omega. Here see V is equal to Vm sin omega t. But here sin 90 minus theta. I want to calculate this omega t minus pi by 2. So just we take one minus of sin omega t minus pi by 2. So this is sin 90 minus theta. Just I want to theta minus 90. So sin pi by 2 minus omega t. So cos omega t is converted to sin 90 minus theta. So 90 minus omega t. So I want to convert this sin omega t minus pi by 2 in term of 1 minus. See common factor. Just I want to take 1 minus. So I is equal to Vm divided by L omega minus into minus plus. So sin omega t minus pi by 2. Sin omega t minus pi by 2. Finally I is equal to Vm divided by L omega sin omega t minus pi by 2. Sin omega t minus pi by 2. This is equation of current in applied source, from applied source. Applied source is equal to applied voltage is equal to V is equal to Vm sin omega t, and the current equation is equal to Vm divided by L omega into sin omega t minus pi by 2. This is the equation. There's another one. I is equal to Vm divided by L omega, maximum voltage divided by L omega. L into omega, angular frequency and self induction. According to Ohm's law, you know well, I is equal to V divided by R. So this is I value, V value. L omega is almost equal to resistance. This is a resistive of the coil. So here omega L is nothing but this is a resistance of the inductor. So I is equal to V divided by R sin omega t minus pi by 2. Just I want to take this. I is equal to Vm divided by omega L is the resistance. I mean this is a reactance of the coil. So just I want to take this XL is nothing but this is L omega. This is almost equal to resistance of the inductor. So omega L Vm divided by XL into sin omega t minus pi by 2. So voltage divided by resistance, you know well, this is a current. So maximum voltage divided by resistance is equal to current. So I is equal to I maximum Im sin omega t minus pi by 2. Sin omega t minus pi by 2. This is the final equations of current. equation. I mean the current equations. I mean alternating current equation. First equation V is equal to Vm sin omega t, but here I is equal to Im sin omega t minus pi by 2. Im is nothing but this is a maximum current flowing through the inductor. So Vm divided by XL. VXL is nothing but this is a reactance, which means the resistance of this coil. So I is equal to Vm divided by XL sin omega t minus pi by 2. So I is equal to Im sin omega t minus pi by 2. Compare equation 1 and 4. Here V is equal to Vm sin omega t. Here I is equal to Im sin omega t minus pi by 2. Minus pi by 2. So this is V is equal to Vm sin omega t. This is I is equal to Im sin omega t minus pi by 2. Compare two equations. The current value is lag of minus pi by 2 values. This is a very important one. V equal to Vm sin omega t, but I is equal to Im sin omega t minus pi by 2. So the current value compared to voltage, the value is lagging of pi by 2 phase angle. Pi by 2 phase angle. So lead value is voltage, lag value is current. The current is lag behind by the voltage of pi by 2 phase angle. Or voltage is lead of current pi by phase angle of pi by 2. It's a very important one. So one more question. Voltage is lead. Compare I. But I is lag. Compare voltage. I value is lagging phase angle of pi by 2. Angle of phase angle of pi by 2. Then voltage. Or voltage is lead. Compare the current. So V is equal to Vm sin omega t. I is equal to Im sin omega t minus pi by 2. So current is lagging behind the voltage of phase angle of pi by 2. So this is lag value, this is lead value. Voltage is lead, current is lag, phase angle of pi by 2. Lag behind lag to the lagging of phase angle of pi by 2 in AC circuit containing only an inductor. This is in this region. Voltage is lead, current is lag value, the phase angle of pi by 2. And next one is I is equal to Im sin omega t minus pi by 2. Sin omega t minus pi by 2. This is equation number 4. So I is equal to Im is equal to Vm divided by XL. Vm divided by XL sin omega t minus pi by 2. Who is XL? The reactance, resistance of this coil. So XL is equal to, XL is equal to L omega. L omega. This L omega is equal to XL. That's why I want to take XL is equal to L omega. So XL is equal to L, self inductance of the coil, and omega is 2 pi f. 2 pi f. Now here very important one. What happened? The alternative current connected with an inductor, AC circuit containing only an inductor. The reactance of the inductor is XL is equal to L into 2 pi f. L into 2 pi f. So XL is directly proportional to f. XL is directly proportional to f. If frequency increases, reactance is also increases. Resistance value is increases. So XL is directly proportional to frequency. In alternative circuit, each and every half circle, well the frequency should be changed, the magnetic flux change, so induced flux change, so magnetic field is also changed. So that's why the alternating, the induced EMF should be developed in the coil. Well. So XL is directly proportional to F. If frequency increases, resistance also increases. If frequency decreases, resistance also decreases. When connected with DC circuit, what happens? I want to calculate the DC circuit. If DC circuit frequency is 0, in DC circuit frequency is 0, so there is no change in flux. There is no change in flux, so there is no induced EMF. So the reactance is 0. XL is equal to 2 pi f into L. So f is 0, so XL is also 0. For DC current, frequency is 0, so reactance, the resistance is also 0. So there is no reactance for DC circuit. So DC current easily flow through the inductor. So there is no, in ideal inductor, there is no reactance, there is no resistance. So DC current is easily allowed to the inductor. But AC circuit is depends upon the frequency. Frequency increases. For AC circuit, frequency varies. So XL is equal to 2 pi f into L. 2 pi f into L. So XL is directly proportional to f. If frequency increased, reactance increased. Frequency decreased, reactance also decreased. The frequency XL is directly proportional in graph value. Frequency increases, XL is also increases. XL is nothing but reactance of this inductor. So frequency XL is directly proportional to F for AC circuit. So AC is almost AC circuit, AC source, flux is changed, so EMF induced in the coil. So the induced EMF against to the applied voltage. E is induced EMF is directly proportional to rate of change of current. So the induced EMF against the source current according to Lenz's law in AC circuit. What happened in DC circuit? In DC circuit frequency is 0, so reactance is 0. Almost the inductor should be act as a ordinary resistor for DC circuit. Ordinary resistor, act as ordinary resistor for DC source. So for DC, F is equal to 0. That's why reactance is also 0. And next one is a phasor diagram. V is equal to Vm sin omega t. I is equal to Im sin omega t minus pi by 2. The current is lag of phase angle pi by 2. So not take this phasor diagram. This is omega t for V value. The maximum value is Vm. Omega t value. This is the voltage equations. The voltage is variable. Alternating current. Variable form. This equation in phasor diagram. But the I value is equal to Im sin omega t minus pi by 2. The lagging of phase angle of pi by 2. Phase angle of pi by 2. This is 90 degree. This is I maximum. This is a phase angle of pi by 2. Omega t minus pi by 2. So this is pi by 2 phase angle for I current, the maximum current. So current is lagging off in voltage in phase angle of pi by 2. Or voltage is lead in phase angle of pi by 2 begin to the current. So this is a phasor diagram. And next one, wave calculations. This is omega t value. This omega t is equal to 0 and pi by 2 and pi and 3 pi by 2 and 2 pi. Just I want to take one single waveform. So apply the sin omega t values. V is equal to Vm sin omega t. Vm sin omega t. V is equal to Vm sin omega t. If omega t is equal to 0, if omega t is 0, what happen? V is equal to Vm sin omega t. If omega t is equal to 0 means V is equal to Vm sin omega t value is 0. So sin 0 value is 0. So V is equal to 0. So first one, this is 0 value. And next one, omega t is equal to pi by 2. Omega t is equal to pi by 2. What happened? V is equal to Vm sin omega t. Omega t is equal to pi by 2. So sin pi by 2. V is equal to Vm. Sin pi by 2 is equal to 1. So V is equal to Vm. V is equal to maximum voltage in pi by 2. This is pi by 2 value is V is equal to maximum voltage. V is equal to Vm. And same one, V is equal to Vm sin omega t. Omega t is equal to pi. Sin pi value is 0. So V is equal to 0 in pi. Further, this is 0. This is pi value. What will happen? 3 pi by 2. 3 pi by 2 V is equal to Vm sin omega t is equal to 3 pi by 2, 270. So 3 pi by 2 value is equal to minus 1. V is equal to minus Vm. So this is maximum 3 pi by 2. And next one, finally V is equal to Vm sin omega t. Omega t is equal to 2 pi. 2 pi is equal to 360. 360 is equal to 0. So sin 0 is equal to 0. So V is equal to 0. This is 2 pi. This is EMF value. I mean applied source voltage. V is equal to Vm sin omega t. V is equal to Vm sin omega t. Applied source voltage. Same one I want to calculate this in current. What happened? Current is equal to I is equal to Im sin omega t minus pi by 2. Minus pi by 2. So I is equal to Im sin, if omega t is equal to, first value is 0. 0 minus pi by 2. So I is equal to Im sin minus pi by 2. So I is equal to Im minus of sin pi by 2. So I is equal to minus Im, sin pi by 2 value is 1. So I is equal to minus Im. So this is negative. The current value is, the I is equal to Im. Current is equal to maximum in negative. Maximum in negative. So this value. And next one is omega t is equal to pi by 2. What happened? I is equal to Im sin omega t minus pi by 2. This is the equation. So I is equal to Im. Omega t is now pi by 2. Sin pi by 2 minus pi by 2. So I is equal to Im sin pi by 2 minus pi by 2, sin 0. Sin 0 is equal to 0. So I is equal to 0 when pi by 2. This is value positive to negative. This value. And next one is pi. What is the pi value? Let's substitute this. What happened? I is equal to Im sin omega t minus pi by 2. The lag of S angle pi by 2. So I is equal to Im sin. Now omega t is pi. Pi minus pi by 2. So I is equal to Im sin 2 pi minus pi. 2 pi minus pi whole divided by 2. So I is equal to Im sin 2 pi minus pi is pi. Sin pi divided by 2. Sin pi by 2 is maximum 1. So I is equal to Im positive maximum. Now if pi value, the I value is maximum. Now well, and what happened? Next one is 3 pi by 2. Next one is 3 pi by 2. Same one. I is equal to Im sin omega t. Now this is 3 pi by 2. 3 pi divided by 2. So I is equal to Im sin, common factor, sin of 3 pi minus pi whole divided by 2. So I is equal to Im sin 3 pi minus pi 2 pi. Sin of 2 pi divided by 2. So 2 cancel. Sin pi value is 0. So I is equal to 0 when 3 pi by 2. 3 pi by 2. You know well. And next one is last one, 2 pi. I is equal to I sin omega t minus pi by 2. I is equal to maximum, I maximum, sin omega t is 2 pi minus pi by 2. C equal to Im sin 2 pi, this is 4 pi minus pi whole divided by 2. So So is equal to Im sin 3 pi, 4 pi minus pi, so 3 pi divided by 2. So is equal to Im sin 3 pi by 2 is value is minus 1. So I is equal to minus Im. See well, the waveform, this is equations of current, this is equations of current. So E is equal to, I is equal to Im sin omega t minus pi by 2. So alternating current equations. This is applied voltage V is equal to Vm sin omega t. A sine waveform, I mean this is alternating voltage waveform. This is I is equal to Im sin omega t minus alternating current equation waveform. See well, if voltage is 0, current maximum. If voltage is maximum, current 0. If voltage is 0, current maximum. The phase angle of pi by 2. Phase angle of pi by 2. This is very important. What is the phase angle between applied voltage and current, alternating current in AC circuit containing only in inductor is pi by 2. If voltage is 0, the current is alternating current source value is 0. This is applied voltage V is equal to Vm sin omega t. This current value is 0. This is maximum. Voltage is maximum. Current 0. The phase angle between voltage and current is pi by 2. For example, a pure inductor of 25 millihenry is connected to an AC source of 220 volt. You know well, millihenry self-induction of the inductor, and next one AC source of 220 volt. The source applied voltage is 220 volt. Given the frequency of source is, source is 50 Hz. You know well, is a AC circuit frequency is 50 Hz. It's a 50 variable frequency. 50 Hz is the alternating source. The RMS current in the circuit is, what is the data? First, just simple one diagram. I want to calculate this inductor millihenry L value and applied with AC source. AC source voltage is 220 volt. Flow current I value. This is a VRMS, this is IRMS. I want to calculate this I value. So pure inductor of 25 millihenry. L is equal to 25 millihenry. So L is equal to 25 into 10 power minus 3 Henry. You know well, Henry is the unit of self-inductance. Connected to the AC source of VRMS is equal to 220 volt applied voltage. Given the frequency of source is 50 Hz. Frequency F is equal to 50 Hz. I want to calculate this IRMS. IRMS is equal to what? So IRMS is equal to formula equal to VRMS divided by resistance. VRMS divided by resistance. Who is the resistance in inducting coil? Is XL. You know well. XL is the inductive reactance of the coil. Inductive reactance is also called as inductive reactance. Inductive reactance, we are using inductive coil, that's why inductive reactance. This is also a resistance reactance. So IRMS is equal to VRMS divided by XL is equal to L omega. XL is equal to L omega. This is XL is nothing but this is L omega. The source, alternating source. So first of all, I want to calculate this L omega value. You know well, VRMS value. So IRMS is equal to VRMS. What is VRMS value? Is 220 divided by L omega. But IRMS is equal to VRMS divided by L omega. L is a constant into omega is equal to 2 pi f. You know well. L is equal to omega is equal to 2 pi f. So f is the frequency of the alternating source. Just I want to directly apply the value. What is L value? L is 25 into 10 power minus 3 millihenry, that's why, into 2 into 5, 22 divided by 7, 22 divided by 7 into F. What is F value? F is 50. So I RMS is equal to 22 divided by 25. Just easily cancel, value is 220 into this 10 power minus 3 goes to denominator to numerator, 10 power plus 3 in 7 into 7 divided by 25 into 2 into 22 into 50. So 25 into 2 into 22 into 50. So which is equal to 22 cancel. This is 10. Remaining 25 into 2 into 50. So this is 7 into 10 power 4 divided by 25 into 2 into 50. 50 into 2, 100. 100 into 25. So 2500. 2500, which is equal to 712,340 divided by 2500. 20 cancel. Remaining 700 divided by 25. Easy cancelling. 5 times 5 5s are 25. Remaining here 1 5. Remaining 2 0 4. This is 0. So 140 divided by 5. Remaining cancel 1. This is 2 5s are 10. Remaining 4. 4 into 0 40. 8 5s are 40. So it is equal to 28 ampere. So IRMS is equal to 28 ampere. See, a pure inductor of 25 millihenry is connected to an AC source of 220 volt. Given the frequency of source as 50 Hz, the RMS current in the circuit is 28 ampere. Next example, an ideal inductor of inductance 50 microhenry is connected to an AC source of 220 volt and 50 Hz. 220 volt is applied voltage, 50 Hz is a frequency. Find the inductive reactance. Find the inductive reactance. What is the resistance of this coil? I mean this coil. Inductive L is equal to 50 microhenry. Applied source value is 220 volt and frequency is 50 Hz. 220 volt and 50 Hz. So I is equal to Im sin omega t minus pi by 2 voltage. The voltage lead to the phase angle of pi by 2. So here inductive reactance. What is the inductive reactance of the current? You know, well, inductive reactance of the current is equal to XL is equal to omega L. L omega or omega L. XL is equal to omega L. You know, well, equations I is equal to Im sin omega t minus pi by 2. Im is nothing but I is equal to Vm divided by XL. So XL is equal to omega L sin omega t minus pi by 2. According to Ohm's law, I is equal to V by R. R is omega L. Here inductive reactance. Inductive reactance. So XL is equal to omega L. So XL is equal to omega 2 pi F into L. 2 pi F into L. So XL is equal to 2 into pi into what is F value? 50 into L value is 50 microhenry. 50 microhenry. Micro means 10 power minus 6. So XL is equal to 2 into pi into 50 into 50 into 10 power minus 6. 10 power minus 6. The XL is a resistance. So the unit of resistance is Ohm. You know well. So voltage divided by resistance is equal to ampere. So here omega L is nothing but almost equal to resistance. That's why we have take to Ohm. So XL is equal to 2 into pi into 50 2500 into 10 power minus 6. 10 power minus 6, which is equal to 25 into 2, 50 remaining to 0 into pi into 10 power minus 6 ohm. So XL is equal to 5. This is 10 power plus 3. This is 10 power minus 6. That's why I want to take this 5 pi into 10 power plus 3 into 10 power minus 6 ohm. So XL is equal to 5 pi into 10 power plus 3. This is minus 6. So 10 power minus 3 ohm. So XL is equal to 5 pi into 10 power minus 3 called as milli. So milli ohm. Milli ohm. This is answer. So inductive reactance of this coil is XL is equal to 5 pi milli ohm.